Today's learning goal is I can use properties of exponents to simplify and evaluate power expressions. You'll notice that this is the exact same learning goal as last time because we're going to continue it with a new property. And the property that we're going to learn today is quotients of powers. Okay, remember that quotient is the answer to a division problem. So here we have 5 to the 7th divided by 5 to the 3rd. Notice they have the same base. Both of the bases are 5. Okay. So here, in expanded form, that's 7 5s at the top and 3 5s at the bottom. Remember that anytime we have the same factor at the top and at the bottom, that just turns into a 1. Okay? So these turn into a 1, which means that we're multiplying by 1, which means it doesn't matter. So we can cross these out. 1 for every 5 on the top and every 5 on the bottom, we can cross out. So there's 3 on the bottom, there's 7 at the top. It means we can cross out 3 from both of them. And I want to do a quick reminder of why we can cross out common factors from the top and the bottom. So let's say I have something like 3 times 5 over 2 times 5. Okay. Remember that this can be rewritten as 3 over 2 times 5 over 5. Okay, so that's because when we multiply fractions, we simply multiply across. Okay, so these two are the same thing. And then we know that 5 divided by 5 is the same thing as 1. So we can rewrite this all as 3 over 2 times 1, which is just anything multiplied by 1 is itself. So this is all equal to 3 over 2. So therefore, these two 5s don't matter. We call these canceling them out. Common factors can be canceled out. If there's a common factor at the top, they can be canceled out with a common factor at the bottom. What that leaves us with is the simplified expanded form, which is 4 5s, like so. Which means that once simplified, we only have 4 factors. Okay. The simplified expression, therefore, is 5 to the 4th. This is 5 to the 4th right here. Here, we have 8 3s at the top and 5 3s at the bottom. So in expanded form, it looks like this. And again, we can cross out any of the ones that they have in common. So this one cancels out with this one cancels out with this one. This 3 cancels out with this bottom 3. This top 3 cancels out with this bottom 3. This top 3 cancels out with this bottom 3. As a result, we have 3 3s left at the top, so there were 3 3s right here. It means there's 3 factors of 3, therefore this is 3 to the 3rd. Okay. Go ahead and try this last one out on your own. Here, we have 6 x's at the top and 2 x's on the bottom, and again, we can cancel them out. This cancels with this one. Let's use a better color. This cancels with this one. This top x cancels with this bottom x. So what we're left with is 4 x's. So therefore we have x times x times x times x. Which means we have 4 factors. So therefore it is x to the 4th. Because there are 4 x's right here. So what you could notice is that if you take the exponents, 7 and 3, subtract them together, we get 4. If we do 8 minus 5, we get 3, which is this exponent right here. And if we do 6 minus 2, we get 4. So the rule is, let A be a non-zero real number, and let M and N be positive integers such that M is greater than N. To divide powers of the same base, you have to subtract. Okay, so what this is all saying is for this algebra one here, is the base is a non-zero number, so this base has to be not 0, which all of our examples so far have been. So this right here has to be not 0. Okay, and M has to be greater than N. So this M, the top exponent, has to be bigger than the bottom exponent. Okay, in such cases. And we're going to learn that that doesn't necessarily have to be true, but we're going to keep that for right now. But we'll learn later on that this doesn't necessarily have to be the case, but we'll talk about that when the time arrives. So here, 4 to the 7th divided by 4 to the 2nd is the same thing as 4 to the 7 minus 2, which is 4 to the 5th, because 7 minus 2 is 5. And for the more general rule, a to the m divided by a to the n is a to the m minus n, where a is not 0. Again, the base has to be not 0, which has been the case so far. So here we have 6 to the 12th divided by 6 to the 5th. Notice that the top exponent is larger than the bottom exponent. And the long way of writing this is the expanded form. So we get 12 sixes at the top and 5 sixes on the bottom. And remember that we can cancel out for everyone that's on the top and everyone that is on the bottom. So we got this 6 cancels out with this 6 cancels out with this 6 cancels out with this one cancels with this one cancels with this one. What we're left with is 7 sixes. And then the shortcut way is 6 to the 12 minus 5. Finally, we get 6 to the 7th because 12 minus 5 is 7, and we can see that we have 7 sixes right here. Go ahead and try this side on your own. What should look like is negative 2 times 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 negative 2, and 4 negative 2's on the bottom. We're going to cross out the ones that we can, the ones that cancel each other out. So this top, bottom, top, bottom, top, bottom, top, bottom. Here, we can do negative 2 to the 7 minus 4. Remember that these bases have to be in parentheses. And that's negative 2 to the 3rd. Over here, for here we have 1 over y to the 9th times y to the 12th equals y to the 12th over 9. The reason for that is, remember that any whole numbers are always over 1. Okay, because it's divided by 1, you can always divide it by 1 and get the same number. And to multiply fractions, you just multiply across. So 1 times y to the 12th is y to the 12th, y to the 9th times 1 is y to the 9th. And now we can use our quotient of powers property. So y to the 12th divided by y to the 9th is the same thing as y to the 12 minus 9. And 12 minus 9 is 3, so this final answer is y to the 3rd. Here, we're going to have to use both the product property and the quotient property. Remember that whenever you're dealing with a fraction, you always want to simplify both the numerator and the denominators first. The denominator is already simplified, there's nothing to do here, but in the numerator we can do this multiplication right here to simplify it. So y to the 2nd times y to the 4th, 4 to the 2nd times 4 to the 8th. You simply add the exponents together for the product property, which gets us 4 to the 10th. And then we're going to use the quotient property to divide. And so that's 4 to the 10 minus 4, which gets us 4 to the 6th. Here we have 2 different variables, and it's horizontal. Okay, this division line right here, this division sign, is going to create a fraction. Okay, so when we take a look at this entire expression right here, this x to the 6th, y to the 3rd, is being divided by this entire expression over here, y to the 2nd, and y to the x to the 2nd, y to the 2nd. Okay, so that's why we can rewrite it like this, something a little bit more familiar. Now remember that you can only use the product property for bases that are the same. So only x to the 6th divided by x to the 2nd, which gets us x to the 4th. Y to the 3rd divided by y to the 2nd, which just simply gets us y to the 1st, or y. Okay, so therefore it's x to the 4th, y. We cannot do y to the 6th minus or divided by x to the 2nd. They have to have the same base.